In this example, you were asked to simplify each one of these expressions. So the thing you have to keep in mind is that you're going to be using exponent rules, but sometimes the exponent rules do allow you to maybe do them in a slightly different order than what I'm going to show, so be aware of that. And also, the understanding is that typically they want you to simplify them completely. That means you should have the variables written with positive exponents only, and any numbers are written in lowest terms. So if you do need to have a coefficient in the numerator or denominator or both, that should be written in lowest terms. So let's look and see how to do these three, and to give more room, just going to separate them like this. X squared raised to the third power, all raised to the fifth. When you do a power of a power, multiply the exponents. This is like having x to the 2 times 3 times 5 power, and 2 times 3 is 6 times 5 is 30. So this would be x to the 30th power. For this one here, you want to square this first. Now, if you're squaring a product, both terms get squared. You have to be aware of when you're squaring multiple variables or raising multiple variables to a power, or just one variable. Like for instance here, only the y is being raised to the 6th. The x is being raised to the 2nd. So for this one here, first you're going to do, to the bottom, you're going to have the x squared and the y squared together, and kind of keeping in mind that there's going to be a coefficient of 1. You don't necessarily have to write it, but you want to keep that in mind. And you're going to basically divide this into 3 division problems. You're going to basically do the coefficients, the powers of x and the powers of y separately. So 7 divided by 1 times x squared divided by x squared, and then y to the 6th divided by y squared. 7 divided by 1 is just 7. X squared divided by itself is just 1. Anything divided by itself is 1. When you divide powers of the same base, you subtract the exponent, so 6 minus 2 is 4, so you have 7y to the 4th. For this third one, there's different ways you could go about doing this. I tend to go often more with simplifying what's inside first and then raising to the power. You can raise everything to the third power, but you have to make sure it's both in the numerator and denominator. And then you're often going to be dealing with bigger values, both in exponents and coefficients. So that's usually why I choose to simplify inside first, because then you have smaller values to work with when you're raising to a power on the outside. So again, I'm going to split this up a bit more than I would normally show, but just to kind of showcase what's going on here. So again, I'm going to do the coefficients separately, the powers of x separately, and the powers of y separately. So here you're going to have 4 over 6 times x cubed over x, which is x to the 1st, and then y to the 5th divided by y to the 4th. 6 does not go into 4 because 4 is bigger, but the fraction 4/6 can simplify to 2/3. X cubed divided by x to the 1st will give you x squared. Y to the 5th divided by y to the 4th will give you a y to the 1st, or just y. Now you're going to raise everything to the third power. So this, both the numerator and denominator get raised to the third power. So you're going to have 2 to the 3rd over 3 to the 3rd. You're going to have x to the 2 times 3 power. You're going to have y to the 3rd, which is just 1 times 3. So here you're going to have 8/27 times x to the 6 times y cubed. And more of the times than not, you're going to see it more or less written as these two values. Since they're technically in the numerator, they're going to just be moved to the numerator. So you might see it written as 8 to the 6 y cubed all over 27. So that is the end of this problem, and that is the end of this video. If you have any additional questions, please make sure to reach out to me during class.